Hi everyone, welcome to this video. Today we're going to have a look at the tan function. And before we start anything, we need to remember a few things. First thing, our tan theta can also be defined as sine theta over cos. And from here we can also say it doesn't exist when cos theta is equal to 0, because we would be dividing by 0. That means it's not defined um, at pi on 2, because pi on 2 is equal to 0, and it's not defined when it is 3 pi on 2 for the same reason. So not defined at those 2 points for those two angles. We can also say that tan of theta is going to be equal to 0 when sine of theta is equal to 0, because 0 divided anything else is always going to give us 0. So there's a few bit of definitions here. Because we've got not defined at these two angles, these are going to be our asymptotes. I cannot spell that. A-S. Okay, asymptotes at pi on 2 and 3 pi on 2. And basically we get the same pattern like we do for sine and cos when we actually start to draw them. The tan graph has a period of pi, which means it does one full rotation or cycle in um, the domain over pi, which means over 2 pi it will do 2 full rotations, or 2 complete cycles. Our range is all real numbers, and we have x-intercepts at x equals 0, pi, and 2 pi. Um, our equilibrium point, or our mean position, is at y equals 0, depending if we move it up or down though. And asymptotes are 1 period apart. So our asymptotes are going to be 1 period apart, and the x-intercepts are also 1 period apart. So just to make sense of what we're talking about, between 0 and 2 pi, we're going to have the tan graph. So this is pi on 2, 3 pi on 2, they are asymptotes, and I haven't drawn it very evenly, but that's roughly the shape that we're after. So this is what the tan graph looks like. Okay, so one full rotation is looks like this. Okay, so for 2 full rotations, has this shape as shown. As you can see, we have 1 full rotation from 0 to pi. In between the 2 asymptotes is also 1 full rotation, as with the x-intercepts. So that's mainly all the bits of information that we need to use for tan to be able to sketch. So I'm just going to pause the video and we can have a look at an example shortly. Righto, so we're going to have a look at this example for sketching tan of x for x between minus 3 pi on 2 and pi on 2. And just like our other trig functions, we can find our period. That's going to be pi for the tan graph. Our asymptotes usually has or always has a asymptote at pi on 2. And because they are period apart, a whole period apart, we can find what our asymptotes are for our domain. So pi on 2 is our first asymptote. Well, let's go backwards because that's our endpoint at the moment. So our other one is going to be pi on 2, and we're taking one period backwards, so take pi. So pi on 2, take pi, will give us minus pi on 2. Okay, this is still inside our domain, so let's see if we can do another one. So pi on 2, negative pi on 2, take another pi, will give us minus 3 pi on 2. So there are our three asymptotes, so 1, 2, and 3. Our x-intercepts are going to occur midway between the asymptotes. Asymptotes. So in this case, halfway between pi on 2 and minus pi on 2, it's going to be 0. And halfway between minus pi on 2 and minus 3 pi on 2, we're going to have minus pi. So halfway between them will give us the x-intercepts. And from there, we can sketch our tan graph. So between pi on 2 and minus 3 pi on 2, this is going to be minus pi. This will be minus pi on 4, pi on 4. So just to break it up a bit, and we can use this to sketch our asymptotes. So first one is at pi on 2. So let's draw those in. The other one minus pi on 2. And the third one over here. Okay, a little bit uneven, that's okay. Now we just have the basic shape of the tan graph, which is usually something like that. So over here, we're going to have our first intercept at minus pi, as we found out. Then it's going to go towards the asymptotes. And then the same thing over here. It's a little bit spaced out, so it goes through 0. Okay, and that's it. Because I need to stop at minus 3 pi on 2, and I go up to pi on 2. So that's example 9. In the next bit, we'll have a look at the next example. Alright, in this bit here, we're going to have a look at example 10. So on the same set of axes, or on the same diagram, we're going to sketch a graph of tan of x and minus 2 tan of x for values between minus a half, or minus pi on 2 and pi on 2. So we'll just look at the first one here, tan of x, and we can put that on our axes already because that was from the past example we did earlier. So from minus pi on 2 and positive pi on 2. These are going to be our asymptotes. We're going to go through 0, so I can sketch that in as something like that. So it looks very similar to a cubic graph. It's not quite the same, but similar shape. And now we'll need to have a look at minus 2 tan of x and just see how that changes. So it has an amplitude of 2 at the front. We've got a reflection in the x-axis based off that negative sign, gives us a reflection, and the transformations don't alter the period and the x-intercept or the asymptotes. We've still got the same period of pi, and we also go through 0, 0. And the asymptotes are the same. So it's going to be very similar to this one. It's just that we're got that amplitude of 2 at the start. It's also been reflected. So on our graph, so it's going to go through 0, 0 because we haven't moved it left or right. We haven't moved it up or down. So it's going to go through 0, 0. We've still got the same period, and we've got a reflection in the x-axis. So very similar shape to this one. It's just that we're going to go the other way now. So if we sketch that in, it should look something like that. So that's for minus 2 tan of x. So very similar, just a bit of a reflection. And for the second bit of this example, we've got tan of x, take the square root of 3. So let's try and sketch this one. So that minus square root 3 gives us a vertical translation down square root 3 units. And we can find our x-intercepts because they're going to be different now if we've moved it down. So we find that when y is equal to 0. So when tan of x is equal to the square root of 3, and we can solve for that between the 2 points minus pi on 2 and pi on 2. So on our unit circle, we've got pi on 2. So between pi on 2 and minus pi on 2, okay, we're going to have a 1 value for that because it's positive and we're only between those two there. Cos is positive in the fourth quadrant, so we don't want that one. So we're just finding what value of tan, or for x is tan equal to square root 3. And we find that it is pi on 3. So x is pi on 3, gives us the x-intercept. Now the transformation does not alter the period or the asymptotes. And we've still got the period of pi, asymptotes of pi on 2 and minus pi on 2. We have been moved down 3 units, so we do need to take that into consideration. So here's my set of axes, and if I say minus root 3 down here, and we've got pi on 2 minus pi on 2, so they're our asymptotes. And just sketching this, we've got a x-intercept at pi on 3, so roughly somewhere over here. So let's draw those in. Should look something like that. Okay, so that's all we need to do for that example. So as you can see, it's pretty much the same. We've just moved down square root 3 units. The next example, we're going to have a look at a period change. So we've got the tan of 4x now. And for tan graphs, our period, very similar to the other functions, it's just pi on n. In this case, we've got a value of 4. So pi on 4 is going to be our period. The asymptotes occur when our 4x is equal to pi on 2. Okay, remember for our tan of x, we had a asymptote of pi on 2, so that just means when x is equal to pi on 2. Now we've got 4x, it just means when 4x is equal to pi on 2, or in other words, when x is equal to pi on 8. So there's our first asymptote between 0 and pi. The other asymptote will occur when we do a full rotation or full cycle. So there's the first one. We will have pi on 8 plus pi on 4, which will give us 3 pi on 8, and we can still keep going. Sorry, I should have said we're looking for values between 0 and pi. We're still less than a full pi, so let's keep going. 3 pi on 8 plus pi on 4 will give us 5 pi on 8. And again, we can do another one. 5 pi on 8 plus pi on 4 will give us 7 pi on 8. And if we kept going, we'll end up outside our domain. So these are all our asymptotes. So 1, 2, 3, and 4. Now our x-intercepts. Okay, when does tan of 4x equal 0? Between 0 and pi. So our x-intercepts are going to be halfway between each of the asymptotes. So first one, pi on 8 and 3 pi on 8, halfway between them. Okay, divide by 2. we will find that it is pi on 4. I think. So it's 4 pi on 8 divide 2, or we can say times half. So these cancel. 2 on 8, which is, so pi on 4. We can also find between these two, and if we do that, we'll find that it is pi on 2. The next one would be 3 pi on 4, and then the final one is just pi. So these are all our asymptotes, x-intercepts, sorry. And we've got a period of pi on 4, and I reckon we can probably start sketching. So let's draw our diagram. We're going in eighths, so let's righto. So just labeling our diagram, and we've got our x-intercepts, our asymptotes at pi on 8, 3 pi on 8, and 5 pi on 8, and 7 pi on 8. And then we can use our x-intercepts and just drawing the shape. Okay, so as you can see, we've got 1, 2, 3, and then 4 rotations or 4 cycles. So I might leave the video there, and we'll finish off the rest in the next one. Thanks.